So this is the last section of the trigonometry. So it's going to be putting everything together. So we learned about the right triangles. We learned how to solve right triangles using SOHCAHTOA. We also learned about the sine law and the cosine law. Okay? So today we're going to use word problems. We're going to take word problems and we're going to solve them using the 3 different methods that we have learned. Now, when you have a word problem, right? So first you want to state the given information, right? So whatever information they have given you, you want to state them, and you probably want to draw a picture. And then you're going to have to choose the appropriate formula, right? Which formula do I use? Thing that you want to eliminate. So you want to, remember we have 3 options, right? We have right triangles, and for oblique you can use sine law or cosine law, right? So you want to, first thing, you want to see if you have a right triangle. Because if you have a right triangle, you're going to use SOHCAHTOA, easy. Okay? Now, there is also the Pythagorean theorem. I don't know if you guys remember that from grade 10. Does anyone remember the Pythagorean theorem? Yeah? Do you remember it? So it's when you have a right triangle, right? And then if you add the length of the hypotenuse squared is of the basis squared. So c squared equals to a squared plus b squared. Who remembers that now? Yeah. A squared plus b squared equals c squared. A squared plus b squared equals c squared. Have you heard that before? Mm-hmm. Yeah. So this is when you have the 2 bases, right? So if you add a squared plus b squared, you're gonna get the length of the hypotenuse squared. Okay, and that's only if you're looking, if you know 2 sides and you're looking for the 3rd side. Okay, you can use that Pythagorean theorem. And it's always C always represents the hypotenuse. Okay, so you can't, if you want to change that formula to solve for the sides, it becomes c squared minus a squared equals b squared, or c squared minus b squared equals to a squared.
Why is that minus?
If you're looking for, if you know the hypotenuse,
yeah,
and you know one of the sides, to look for the 3rd side, you're gonna bring the a squared over, right? So that means it's gonna become minus.
Okay.
Right? That's only if you know the hypotenuse and you're looking for the 3rd side.
So what if I'm looking for B?
If you're looking for b, right, you're bringing the a squared over, so that becomes c squared minus a squared. Okay? If you're looking for a, you're bringing the b squared over, so it becomes c squared minus b squared. Okay? This is always, c is always the hypotenuse. Okay? Are you guys okay with this? So what does SOHCAHTOA stand for? Sine is what? Sine, the angle is equal to what? O, which is opposite, over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tan equals Labeling your triangle is very important because if you label it correctly, then you can use the right ratio. Now, so if it's a right angle triangle, then you use Pythagorean theorem. It depends on what is given to you. Okay? The Pythagorean theorem, again, you only use it if you know two sides and looking for the third. So if you don't know any angles, you just know the two sides, you're looking for the third, then you use the Pythagorean theorem. Now, if I have a non-right angle triangle, can I use SOHCAHTOA?
No.
No. Right? I have to pick between sine law or cosine law. Okay? So the sine law, which we learned that yesterday, has two formulas. Right? They're the same, but they're inverted. So you have A over sine A equals to B over sine B equals to C over sine C. Right? And the other formula would be, it's the same thing, it's just inverted. Sine A over A equal to sine B over B equal to sine C over C. Okay? This one I use when I'm looking for side. And this one I use when I'm looking for an A. Now, when do you use the sine law? What must you have?
Two sides and angle, or two angles on one side?
That's right. Two sides and any angle, right? Two sides and an opposite angle, I should say. Or two angles at any side. Okay? So let's look at the two different scenarios. So if you triangle, and if you are given two sides, so let's say this side and this side, okay? What angle must you have? Because it's two sides and an angle. So what angle must you have? B or A. Because you must have an opposite angle, right? So if they give you B, right, that's an opposite angle. They give you A, then you can, they give you A, then you can solve for angle A. Okay? Because remember with sine law, you must have the opposite. Okay, you're solving for the opposite. The other situation is when you have two angles. Let's say they give you angle A and angle C, right? And any side, it doesn't matter which side. Even if they give you this side, you can solve for side B. How can you solve for side B? For angle B, sorry. Minus A and C by 180, because all three angles inside the triangle equal to 180 added up together. Okay? So you can find the third angle by doing 180 minus A minus C, and then you can use the sine. It's always easier to figure out if you have the cosine law, if you can use the cosine law first, and then if you can't, then for sure it's going to be the sine law. You have no other options. Okay? So the cosine law, when can I use the cosine law? What are the two situations?
All sides.
All sides are given, or two sides and the angle in between them, right? So these are the only two cases where you can use the cosine law. Then if it's not a cosine law, what must it be? The sine. Okay? Cosine law is, there's two formulas again. Well, there's two formulas, but the letters can change, right? I'm gonna use the a squared equals b squared plus c squared minus 2bc cos angle A. This is if you're looking for side A. And then if you're looking for the angle, it would look like this. Okay. So, here is the map that I want you to look at. Okay? So, is the triangle, the first question you're going to ask yourself, is the triangle a right triangle? If the answer to that is yes, then you can use the primary trigonometric ratio, which are the SOHCAHTOA. Okay? Or Pythagorean theorem, which I told you you only use if you have two sides and you're looking for the third. If the answer to the right triangle is no, then you have two options. Okay? Sine law or cosine. So let's see. Are you given two angles and one angle and an opposite side? Are you given two angles? Right? Or one angle on the opposite side? If yes, then you use the sine law. If no, then you're gonna use the cosine law. Okay? Again, it's easier to know if it's cosine first, and then from there you're gonna move to the sine. Okay? You're gonna always ask yourself, what is the missing variable? What am I looking for? Okay? So you solve for the letter, the missing variable that they're looking for. Make sure the answer,
Okay.
That's what I was thinking, but why do I have this here? And then write a final statement. Also remember that angles should be to the nearest degree, no decimal. Sides, 1 decimal. And when you have ratios, you're going to leave it to 4 decimals. So when you do sine 50, let's say your answer should be to 4 decimals, or cosine 60 should be to 4 decimals. When you're answering sides, 1 decimal. When you're looking for the angle, just leave it to the nearest degree. Ratios. So let's look at the first example. From the top of the Niagara Escarpment, one sees the car below at an angle of depression of 40 degrees. He's approximately 100 meters above the car. How far is the car from the base? And round your answer to the nearest meter. In this case, they are specific that they want to the nearest meter. Okay? If the question specifies what they want, you're going to forget about this, about what I just wrote on top of this. You follow what the question is asking you. Okay? But in the case where the question is not telling you to what decimal place, then you have to follow these rules. So let's read that again. So Juan is standing at the top of that tower, okay? And he's seeing a car at an angle of depression of 40 degrees. So the tower is standing right here, right? That's the tower. Looks like it? No, it doesn't. It's okay. Juan is standing right here. Where do you think the car is going to be? Okay, the car is right here. Okay, this is how can I do. So this is the car, right? It's at an angle of depression of 40 degrees. So he's looking down, right, at that car. Where would that angle of 40 degrees be?
Where was the car? Like isn't it down?
Where?
Isn't it at the bottom, right?
Right here?
Yeah.
It's technically right here.
Isn't that? I thought that's elevation. Depression, elevation.
Depression. Depression is looking down. From the horizontal, not from the vertical. So when you're measuring that 40 degrees, it's gonna be right from the horizontal down. Now, if you put it right here, you're gonna get the answer correct, because technically this is gonna be 40, so this is gonna be 50, right? And then you're gonna end up having a 40 here. Okay? Technically, you're gonna end up having a 40 here, but I'm looking for this to be the angle of depression. Okay? Let's see, what else do we need? We know that Juan is approximately 100 meters above the car. So what is 100 meters above the car? Where would that be? Where would that 100 meter be? The tower, right? So he's 100 meters above. And you're looking at how far is the car from the base of the tower. So you're looking at this. We know it's a right angle triangle because the tower has to be vertical to the ground, right? It has to be 90 degrees to the ground, otherwise it's a leaning tower, okay? All right, so let's name it. So we're gonna name it ABC. Doesn't matter which one you call A, which one you call B, which one you call C at the end. If this angle right here is 40, what would this angle be?
50?
And why is it 50?
Because it has to equal 90 degrees.
It has to equal 90 degrees because remember horizontal and vertical, they make a 90. Okay? So that means this is 50 degrees right here. What's my angle of focus? Which one is my angle of focus? The 50. The 50 is my angle of focus. 40 is outside the triangle. I can't count it. Right? The 40 degrees is outside the triangle. My triangle is right here. Do you guys understand that? So this is my angle right here, my triangle. Right? The 40 is outside the triangle. 50 is my angle of focus. When I have a right angle triangle, I have to label the opposite, adjacent, and hypotenuse. Where do I start?
The hypotenuse is C.
The hypotenuse is C, which is this A to B, right? So that's the hypotenuse. Okay, good. What else?
The opposite would be 100.
The opposite would be
100.
the opposite would be the question mark.
Why?
Because it's opposite from the 50.
Oh, yeah.
Then the 100 is the adjacent. Right angle triangle, that means I have to use SOHCAHTOA, right? I know the adjacent, and I'm looking for the opposite. AO. Which one do I use then? 10. AO, right? If you go back here, this one is the one that has the A and O. Okay? So I have to use 10. Now I wrote the formula down. I'm going to fill out the information. So 10, 50 equals to the opposite, I don't know. The adjacent is 100. All what I have to do is cross multiply. And then find the answer. What do you guys get?
119.
19. So therefore, the car is 119 meters away from the base. It takes time to read the question and understand what the question is asking you for and how to draw the picture.
I don't get 140 the other side. 530 the other side.
Because it's an angle of depression, and remember the first definition that we looked at, angle of depression is the angle measured from the horizontal, right? If you measure, if you think that this is the 40 degrees, why is it wrong? Because you're not measuring from the horizontal, you're measuring from the vertical, right? So an angle of depression, remember that the definition is measured from the horizontal. Same with the angle of elevation. Angle of elevation is measured from the horizontal up. Are we okay with this?
So for that, you take that one and then minus that by 90?
That's right, because remember that the horizontal and the vertical, right? They're at a 9 degree, right? So because I have the horizontal here and the vertical here, so both of these angles are going to make a 90. I know this is a 40, so subtracting 90 minus 40 is going to give me 50. Is that okay for everyone? All right. Micah is standing on the ground between two buildings on the opposite side of a park. The top of the first building is 152 meters from Micah and at an angle of elevation of 38 degrees, while the top of the second building is 157 meters from Micah at an angle of elevation of 53 degrees. How far apart are the top of the two buildings? Round your answer to the nearest meter. Start by drawing two buildings. Put two lines for the buildings. They don't have to be equal to each other. Now put a person in the middle. Draw a line from that person to the top of the building and draw a line from that person to the top of the other building. So, first building, second building, person in the middle. I know that the top of the first building is 150 meters from Micah. So the top of the first building is 152 meters. And it's an angle of elevation of 38 degrees. Where would that 38 degrees be? Angle of elevation. The bottom right. Because angle of elevation means you're standing right here, and then angle of elevation from the horizontal. The top of the other building is 153 meters, or 175, sorry. And is at an angle of elevation of 53. Yes or no? Do you understand that? When I said it? When I showed it to you, do you understand it now?
Yeah, but I still don't picture that though.
Take it piecewise. Now the question is asking you how far apart the two buildings. So what line am I looking at? I'm looking for. Huh? How far apart are the top of the two buildings, not the bottom?
Top of both buildings?
Yeah, how far apart are they? So what do I have to do? I have to draw a line between the top of the two buildings, right? This is what I'm looking for.
Would you find the angle in the middle of the two, like the one above
Mhm.
him, by subtracting the two numbers from 180?
And why 180?
Because a straight line is 180 degrees.
That's correct. So if you look at a straight line, do I have it here somewhere? No. A straight line, the angle of a straight line is 180 degrees. Okay? So if you look at this right here, this is a straight line, right? So from here to here, it should be 180. I know that this is 35 and this is 53. What would this angle in the middle be? I'm gonna call it angle A. What is it?
89. Is it? Am I right?
Yep. 89? Now, I want you to look at this triangle right here because I'm trying to solve this, right? Eyes on the board. Is it a right triangle?
Is it cosine?
It's cosine. Why cosine?
Because it gives you angle between the sides.
Angle between the two sides. You have side, angle, side. You have two sides and the angle between them. Remember? Two sides and the angle between them. This is one of the examples of cosine law. Okay? So, I'm looking for side A. Let's call it A. What would the formula be if I'm using cosine? A squared equals
B squared plus C squared 2 BC
BC
cos
cos A. Good. Call them B and C, right? And plug in the information. Remember I told you when you plug in the information, I want you to do the whole thing all together. If your calculator is forward. If your calculator is backward, come and see. That should be squared, not 2. I don't know where I got this tape. Point.
4682.
So a squared is this. Is that my final answer?
No.
What do I have to do?
Third.
Square root. So if I square root, what do I get?
233.
And then nearest meter, so that's 233 meters. I don't need any decimals. And this is my answer. Therefore, the two buildings
Should be
to the
234.
top of the two buildings. Sorry?
234.
2, 3, 4.
Yeah, I did math before.
The top of the two buildings are 234 meters apart.